Before we start the video, let me give you a brief introduction about myself. I'm Chandresh Mahajan, who is founder and chief educator at Exergic, which is India's most trusted and comprehensive institute for online gate preparation. I got an All India rank 37 from Gate Mechanical Engineering, and I am an ex Indian Oil officer, having 6+ years of teaching experience as of now. To know more about our GATE courses, you can contact us on these details. Also, you can download Exergic GATE preparation app from Google Play Store. The link is available in the description of video.
Now, suppose there are two friends, and one of them is person A, and let's call the other one as person B. Okay, so A and B are good friends with each other, and they are studying in the same college, let's say, and one of them got placed. Okay, let's say person A, he got placed in a good company. On the other hand, person B is not placed. He did not get placed. So what happened next is that person A happily joined the company, but on the other hand, person B thought of applying in different companies, or rather, let's say person B decided to prepare for an exam. Okay, prepare for an exam of, let's say, any clerical exam in the bank, which is going to be after 1 year. So what B decided is to sit at home and prepare for that exam. On the other hand, A is going to join the company next month. Now what happened is that when A joined the company, due to his activities, let's say, he was fired from the company in 2-3 days. Okay, so now he is jobless. What he did is that he again applied in some other company. He waited for some days, applied, and then he got the job again. But again, due to some situations, in 3-4 days he was fired and he was kicked out of the company. He said, okay, no problem, let's try again, let's apply again. He again searched for some company, again applied, again due to some reasons he was kicked out of the company, and this process went on for, let's say, 8 to 9 months. So for next 8 to 9 months, what is happening? Person A is searching for some company to apply, he's applying, he's getting the job, and after 2-3 days he's being fired, he's being kicked out from the company, he's being expelled from the company. So it is happening for next 8 to 9 months. Now imagine what is going to happen. Will he consider applying for some other company? He will. I think he's totally shattered, he's totally broken, totally failed. He does not want to apply to the next company because he has done everything that he could. He applied to different companies in different sectors, but every company threw him out after 3-4 days max. So now you compare him, person A, with person B. Both of them are jobless now. Both of them do not have a job right now. Person B is sitting at home happily preparing, very hopeful for his exam and preparing for the exam. But on the other hand, person A is at such a state that he considers himself as a total failure. He does not want to do anything. He does not want to apply anything. He thinks that he is the most undervalued person, and he considers himself as a total failure, because in last 8-9 months 50-60 companies have just taken him in, and after 2-3 days they kicked him out. So he must be feeling very bad about himself, totally broke. Now you compare both of them, then you will see that B is at a better stage than A, because both of them are not employed right now, but B is hopeful that he is going to make it, he is going to try, but A has completely failed, completely shattered, and completely hopeless. Now if you compare the journey of 8 to 9 months of both of them, then in terms of number, if you would say, then A has been placed on more number of days as compared to B. So he was working for 2-3 days, then he was being kicked out, then 2-3 days in some other company, then kicked out. In totality, he has worked for around, let's say, 30, 40, 50 days, but he has been not employed throughout this time. So if you look at the number, then you will think that this person should be happier than this one, because overall he has been employed for more number of days than him. But if you compare them at this state after 8-9 months, you will see that opposite is there. This person is totally shattered and considering himself as a failure, but this one is hopeful about the future. Why this happened? In terms of total number of days, he is more employed, he earned maybe more than him, right? But he is totally shattered now. Whether on the other hand, he is totally hopeful and happy right now. This situation reached because, not because of the magnitude of the problem, but because the problem was, keep on coming again and again and again, right? This person was failing every time he was getting kicked out of the company. So he faced more number of problems, repeated problems again and again and again, as compared to this one who just faced a single problem, that he was not placed. So the thing that I want to convey is, I'm writing that thing here, and it's somewhat philosophical sentence if you compare with machine design, but the sentence is that it is not the magnitude of problem that breaks us, rather it is the frequency or repetitiveness of problems that do break us, right? A very practical example I have given you to prove the same. You can think of many other scenarios like this. Now, why I am telling this to you right now? The reason I am telling you this story to you right now is to make you understand that this happens not only in our lives, but also in the life of a component, of a material. The material or the component does not break because of the magnitude of stress. It is not going to break. I'm not saying that it does not break. It breaks due to magnitude of stress, but the major role in failure of components is not of the magnitude of the stress. Rather, the role in their failure is of frequency or repetitiveness of the stress. So what I want to say here is that for components, the failure occurs not mainly due to the magnitude of stress, but because of fluctuating or repeating stresses, right? And this is actually true. In the beginning of this unit, I told you that maximum components in the industry fail due to fluctuating stress. Whatever design you are making, you have already considered the factor of safety. You have already considered all the possible scenarios that can happen in the life of that particular component. You have used a suitable component, you have used the suitable factor of safety. So there are very less chances that the value of stress is going to cross the failure stress or maybe the yield stress. So there are very less chances that for any component for which you have done the calculation, the stress will cross the dangerous value. It will cross the upper threshold. Then how do they fail? Why do they fail? They should work for infinite years. Because of fluctuating stresses. Because the stress to which it is subjected to may not be very high, but it may be repeating. It may be, acting again and again and again. So even though the value of the magnitude of that fluctuating stress will be way below the value of yield stress or the fracture stress or the ultimate stress, still, if that stress is being applied again and again and again, it will fail it. Overall, if you compare both of them, he is having job for more number of days, right? Overall value of stress, mathematically if you see, then it has less stress, less problems, because he is employed for more number of days, he is having money for more number of days. But since problems are coming in again and again and again, he fails first, right? So I think I have given a very suitable example for you to understand this. And as I told you, in industries, more than 90% of the components fail due to fluctuating stresses and not due to the stress being too high or stress crossing the ultimate stress value. More than 90%. And this is not a number that I'm just saying because 90% is a large number. It is a practical observation and proper theory that more than 90% components genuinely fail due to fluctuating stresses. That is why it is more dangerous than all of those static stresses that we consider. Okay, I will explain this to you again with a very simple example. Suppose you have a wire, a steel wire, okay, like this. And if I ask you to break it, then I doubt that many of us will be having the strength to just, bend it and break it, or just pull it and break it. We won't be able to do that, I think. But there is a way in which you can do that, and I'm sure that those of you who have played some outdoor games at some point or the other, they have done this, that they bend it in one direction, then in other direction, then in one direction, then in other direction, right? So if you bend it like this, then you bend it up again. So what is happening here? The upper part is subjected to tensile load, lower is compressed. But on the opposite cycle, upper part is subjected to compressive, lower is subjected to tensile stress. So if you repeat this again and again and again, you will see that in this region where it has maximum curvature, maximum bend, at that region it will start to thin out, it will start to break first, right? You can try that if you have not done, but I think if you have played enough outdoor games, at some point or the other you have done this. Okay, so what is happening here? Same thing is happening. The stress that you are applying is not crossing the fracture stress. Still, the value of stress being very less than fracture stress, but since you are applying it again and again, some part it is tensile, then it will having no stress, then it will be having compressive, then again no stress, then tensile stress. So you see, it is completely fluctuating. The stresses are actually completely reversed. If I tell you the specific type of fluctuating stress, then it has completely reversed stress. At the same point, it is tensile by the same magnitude, let's say, and if you bend it by the same magnitude in the other direction, it will have same magnitude of compressive stress. So that completely reversed stress, even if it is very less than the ultimate stress, is going to fail it, right? Such type of failure, which occurs not due to high value of stress, not due to static stresses, rather due to fluctuating stresses, any type of fluctuating stresses, maybe repeated stress, maybe completely reversed stress. So such type of failures are called as fatigue failures. Fatigue failures. Now, if you know the meaning of fatigue, it means to get tired. If you are fatigued, it means you are tired. So what is happening here? Same thing is happening. This person is tired of applying and getting rejected, right? He is total, if you compare the overall aptitude or overall skills, then maybe he is more skilled. He is at least getting the job again and again. Something must be good in him. But if you look at the overall situation, he is just tired of doing this. He is just shattered of doing this, right? So he failed by being tired, right? This particular component failed by being tired, you can say, right? Again and again, same type of stress is being applied. Tensile, no stress, then compressive. So such failures due to repeating or fluctuating or completely reverse stress or any type of fluctuating stress are called as fatigue failures. Okay. Now we are going to discuss more about fatigue failures, that why they are dangerous, what are the factors that affect fatigue failures. So all these things we are going to discuss now. Now moving ahead with the discussion about fluctuating stresses and fatigue failures, I told you that maximum failures that occur in industrial components are due to fatigue failure, right? So fatigue failures are not only high in the frequency, but also they are high in their risk. What I mean to say is that it is more risky to have a fatigue failure than to have a failure due to static load. And why is that? Look, I am going to give you two reasons for that, which are very important reasons, and they can be asked as theoretical questions in GATE. So the first reason why fatigue loads or fatigue failures, sorry, why fatigue failures are more risky, more dangerous as compared to static failures. So the first reason is that they occur at comparatively lesser value of stress. This is something which you would have guessed already, right? Because they can even occur at lesser value of stress when you are not expecting it, when the component is subjected to such a condition where the amount of stress applied will be high. So that is the region where you are expecting that it will fail. You will be extra cautious about it. But if a component is used at a place which is not subjected to very high stresses, so you will be casual about it. You won't do very frequent inspections and very frequent repairs and maintenance because you think that it is a very insignificant component. The value of stress is not high, but that can fail, and the result of that failure can be very critical, right? It is not that the part should be very important, then only you are going to take care of it. It's not like that. Even a small string which is hanging some weight, if that fails, then that weight will fall, and that may be fatal to someone's life. Even if a small nut or small bolt fails, that can also be dangerous, not only to the machine but also to someone's life. So you cannot say that some part is insignificant, some part is significant. There are significant, insignificant components, I'm not saying that, but you cannot just say that if the value of stress being applied is less and you think that the part is not that significant, so you can ignore it, right? You cannot do that, especially not when it can be subjected to fatigue failures, when fluctuating stresses are being applied. So this is the problem, that you cannot accept or reject any particular component just by looking at the value of stress. You cannot say that that component is not risky because it is subjected to lesser value of stress, or that component is risky because it is subjected to high value of stress. You cannot do that, right? So this makes the fluctuating failures or the fatigue failures even more dangerous, right? That because they can happen even at the lesser value of stress when you are not expecting it, right? Second reason is, and it's very important reason, is that the type of failure that occur when it is fatigue failure is sudden and total. It's a very important term, sudden and total. Sudden and total. Look, I'm going to explain it to you now. That suppose you have any particular component which is of ductile material, okay, and it is subjected to a static load, and the load is being increased continuously. So what's going to happen? Load will keep on increasing, it will reach the yield stress, then it will start to yield. There will be a significant amount of plastic deformation. We already know that ductile material subjected to static load undergo significant plastic deformation zone. So it will have elongation, it will thin out, and ultimately it will go and fracture and fail, right? So suppose you have a string or you have a wire of ductile material from which some weight is hanging, and due to some reason the weight was heavy enough that the wire started yielding. So you will be able to see the yield, right? You will be having time to become cautious that it has started to yield. I need to reduce the weight, I need to do something to take the weight off so that no one gets hurt, the machine does not get hurt, the component does not get hurt, right? So that is an advantage that you have with static load, that there is a warning of the danger, right? The elongation that is happening, the plastic deformation, is a warning that it has started to fail now. You must take action, otherwise some major loss can occur, some injuries can occur. But in case of fatigue failures, even if the material is ductile, for brittle there is no such warning anyway. For brittle material, even if it is static load or fluctuating load, there is no warning because the plastic deformation is not there. But for ductile material, plastic deformation was there in static loading, so it was a warning, a type of warning. But in case of fatigue failures, even if the material is ductile, there is not going to be any significant plastic deformation. You will be able to see that this is the ductile wire, and suddenly the next instant it will break. If it is breaking due to fluctuating stresses, due to fatigue failure, there is not going to be any significant plastic deformation where you will be able to see that okay, it has started to yield, I need to do something. no warning at all. The fracture will be sudden and total. Total means totally it will break. It's not like that some part of it has broken and some is yet to be break. Nothing like that. Sudden and total. So no warning at all. So such things are making it dangerous, right? You are not able to take any preventive action. You are not able to do anything to stop it from happening. There is no signal, there is no warning at all when it is fatigue failure. So that makes them even more dangerous, right? So these are the two things that you must keep in mind regarding fatigue failure. First is, it is dangerous because it can occur a very lesser value of stress as compared to yield stress or fatigue or ultimate stress. And second is that there is no warning. Fracture is sudden and total, right? So this is what you need to know regarding gait. Now there is something extra that I am sharing with you right now. You might not be asked this in gait, but you should know about it. It's not a problem to know. Look, you must be thinking that why such failure occur, how such failure occur in case of fluctuating stresses for ductile material, why there is no yielding, why the fracture is sudden and total. Look, the main reason for this is that generally the stresses which are there in case of fluctuating stresses are lesser than the yield stresses, right? So the point of yielding is anyway not there because the stress is not high enough to make it yield. So there is no yielding, there is no signal of it. Then how is it failing? Look, if you have a component like this which is subjected to fluctuating stresses, let's say, okay, the stress is fluctuating, and as I told you that whatever be the type of material, no matter what material you used, what manufacturing process you use to manufacture the component, there are going to be some defects. There are going to be defects in the material, in the process, irrespective of what you do. You can only control the magnitude or the extent of those defects, but there are going to be defects. There will be certain cracks. Every surface has certain amount of cracks. There will be some notches. There are going to be irregularities in the component. There will be some, forget about those defects. By the design of the component itself, there will be certain holes, some oil holes will be made, some grooves will be made. What I want to say is that there will be some regions which will be subjected to higher value of stress as compared to the bulk of the material. Exactly what we studied in stress concentration, right? Due to such cracks, due to such defects, due to some shape of the component, the stress was increasing locally in some of the regions, right? The same thing I am telling you here. So what is going to happen? Suppose due to stress concentration in some of the regions, the value of stress rises. So what is going to happen? That whatever small defect will be there, suppose this is a small defect that was present, a small crack. As a result of stress concentration, the value of stress near this region will be high as compared to rest of the regions. Okay. So the chances of failure or chances of localized yielding or localized fracture will be more near this crack, right? So what will happen? This crack will start to propagate over time. I'm not saying it will happen instantaneously. Over time, due to fatigue stress being applied, that particular part which has higher value of stress as compared to the other regions is more prone to failure, more prone to crack propagation. So that crack will start to increase. The size of that crack will start to increase. That is technically called as crack propagation. So as the size of crack will increase, more stress concentration effect will be there. So stress will increase even more near this crack. So it will again, the crack size will again increase more. But keep in mind that on the bulk nothing is happening, because in general in other regions the value of stress is way below yield stress. So there was some crack which you were not able to see. There are so many components around in any industry. No one is able to see each and every crack at all the surface, and obviously not on the interior by naked eye, right? So you cannot have a signal for it. So the crack will start to propagate. It's a cumulative effect. More concentration, stress concentration will be there. More stress will increase, more the crack will propagate. Again, due to crack propagation, more stress will be concentrated. So it's like a loop, infinite loop. So over time, what is going to happen? The crack will get long and long and long. A time will come when the stress concentration will be so high that the rest of the region will be subjected to higher value of stress. Right now, it was just, it was just restricted near the crack, but now the crack has been elongated so much that the entire region is at risk. The entire cross section is at risk now. What is going to happen? As the value of stress in the rest of the region increases a certain value due to fluctuating stresses, there will be a sudden fracture of that without any yielding. So there are two faces actually. If you look at its cross section, there are two types of surfaces that you will see. One surface will be formed due to slow propagation of the crack. I'm just assuming that crack was here on the surface and this is how crack propagated. But the rest region will be due to sudden fracture. So this region will be having fibrous structure in the form of very silky shiny fibers, and this part will be having coarse granular structure. In general, if you compare this with the failure of any cross section when it was subjected to static load, any ductile material subjected to static load, then in that case the surface looks very silky fibrous type of failure, because actually what was happening here, it was getting elongated, right? So all the fibers, whatever will be the fibers of that material, they are going to stick out of it. It will be a very fibrous type of structure, appearance wise I'm saying. But in this case, if you see, it will be clearly divided into two regions. One will be more shinier than the other. So by looking at the cross section also, you can tell that whether it has failed from fatigue failure or it has failed from failure due to static load. So as I told you, this is not something which has been ever asked in GATE. I'm just giving this as extra knowledge to you. So if such question comes that how can you decide the type of failure depending upon the cross section or depending upon how the crack propagated, so this knowledge is going to be useful for you at that point of time. Okay.